The Nintendo GameCube is one of the best consoles ever made due to its unconventional look and feel. There's a reason why Nintendo ports the GameCube controllers to the Wii U and even to the Switch. However, the GameCube was meant to be played on TVs like this, with a maximum resolution at only 480p. Playing on newer TVs won't look so good as well due to the higher resolution that newer TVs have. Of course, you could go with something like the OSSC or any other active adapter box to help with these limitations, but those usually don't apply any other graphical enhancements like anti-aliasing. Our savior here is emulation. So how can we create an emulation experience that comes as close as possible to the original? The answer is a sleeper GameCube emulation PC that comes as close as possible to the original GameCube gaming experience. I wanted to get as close as possible to the original boot sequence. There, I used a Linux distro like Ubuntu, where the boot sequence can be highly customized. In addition, I wanted to use a software called RetroPie. It comes with a nice controller-supported interface to select our games. It also supports Dolphin integration, which truly is the best emulator for GameCube out there. It lets us run games at 1080p with anti-aliasing and can also apply a 16:9 aspect ratio to our games. I've created a GitHub project that transforms a PC into a system that achieved all of those requirements. Within the project you will find my code that applies all the boot customizations and installs RetroPie as well as Dolphin. Both of them are configured for this project. I have also created a highly detailed documentation that covers the whole building process. It also provides detailed knowledge about the Linux customizations that were done during this project. For example, if you want to build the same, but for the Nintendo Wii, this guide will assist you and give you tips and tricks to achieve it. So let's do a quick recap and define the definite goals for this project. We want to emulate GameCube games at 1080p with 4x anti-aliasing and 60:9 aspect ratio, a boot sequence that comes as close as possible to the original system, a nice looking game selection screen and as few emulation issues as possible. As for the actual hardware build, I want to keep the original case as unaltered as possible. Original controllers should be usable at the front like they do on the original console. The original power button should be used to power on the system. A new case fan is needed due to the extra heat created by the new CPU. And at last I want to replace the power light. Please don't forget that this is my first ever sleeper PC build, so there definitely is some room for improvement on some things. So let's start with the teardown. I've ordered a used GameCube in great condition online. I specifically wanted to buy the DOL001 model due to its power button and the mounting mechanism that has a few additional advantages for this build. That's because the component holds the power button as well as the case fan at the same time. And that will make it easier if we want to mount the whole thing back into the case. One thing I wanted to mention here is that I later used the power button from an American GameCube. it has a few advantages when it comes to mounting it back into place. Let's take a look at the original motherboard. It holds an IBM PowerPC chip clocked at 485 MHz and an ATI GPU clocked at 162 MHz. If I wanted to determine which CPU is good enough for emulation, there's not really a good mathematical calculation. Other parts on the board, like microcontrollers, needs to be simulated as well, and those would be added to the calculation too. If you multiply the megahertz counts of the CPU and GPU by 5, we should get close to the actual requirement. Don't forget, the CPU needs also to power an underlying OS and Dolphin itself, so we need a little bit more. The bottom part of the GameCube has lots of plastic standoffs and mounting holes that we need to remove in order to fit the motherboard in. I used a soldering iron as well as a Dremel to remove as much plastic as I could. Throughout the project, the proper protection is always needed, so make sure you have the proper respirator, safety glasses and the right gloves. The high friction causes the plastic to melt. This emits not only plastic microparticles, but plastic gases as well, so the proper protection is needed. Now I want to permanently join the expansion slot cover plates to the rest of the case. I melted the plastic to join them together. I used a wider soldering tip and carefully pressed it right along the line where the cover plates touches the case. Here you can see how the cover plates are joined to the rest of the case. Those two red circles show two sample melting points that I did. As you can see, the plates are sitting where they should. Next, I'll build the actual PC. I found a PC that houses a motherboard that had exactly the right dimensions to fit inside the GameCube's case. It was mounted onto a motherboard tray that I first had to remove. The PC itself is the ASRock Desk Mini X300 with a motherboard form factor called Mini STX. As this case has limited space, a dedicated graphics card isn't an option. Therefore, I went with an APU build. So let's install the new APU. I went with an AMD Ryzen 7 5700G. It comes with 8 cores with a base clock speed around 3.8 GHz and a TDP of 65 watts. However, the CPU is an absolute beast when it comes to onboard graphics. It has 8 cores Radeon graphics clocked at 2 GHz, so it should be able to emulate GameCube games with little to no flaws whatsoever. Next up, I installed a CPU cooler. It comes together with the ASRock PC and has exactly the right TDP for my CPU. This one is also very convenient for the build due to its low profile design. With the DDR4 Kingston Fury 32GB dual kit clocked at 3200 MHz, this should be the highest RAM configuration available for this board with the highest specs possible that does not cost over 250 euros. For storage, I want to boot the system as fast as possible without having to pay high amounts of money. So I went with Samsung's 970 EVO Plus PCI Gen 3 SSD. It has decent read-write speeds and should be right in the middle between EVO and Samsung's Pro SSDs, which are more expensive. Now I install the motherboard into the bottom part of the GameCube case. I want to glue it into the case and therefore we need to roughen up the CPU cooler backplate, so the glue has a better hold to it. I cleaned the backplate afterwards with some alcohol to remove the residue. There are many different ways to mount the motherboard into place. I tried many different options and you could go with using a 3D printer or go with a thin metal plate and add mounting holes to it. Unfortunately, all of those mechanisms have one big disadvantage: the height. So let's do some test fittings before actually gluing it down. Also, we want to loosely put on the IOShield to see if everything aligns good with the case. Gluing it down with some strong adhesive will result in not being able to remove the motherboard again afterwards. This is usually bad, but okay for me as I can still remove all the other components. The adhesive has been added now and the motherboard will be set in the case as evenly as possible. The glue now needs to harden for 1 day. After 1 day of drying, it's time to install the new CPU fan. I wanted to reuse the original mounting piece. Therefore, I needed to remove the old fan from this case fan chassis. As you can see, this DOL001 component has the power button directly on it with an exposed PCB. It was a bit harder to find a fan that fits inside this component, but I found one that satisfies all of my needs. This fan right here has exactly the right dimensions and was the quietest I could find at 16 decibels. This should be fine for the new build. In order to fit in the new fan, I had to remove the plastic mounting holes inside of the chassis for the old fan. So let's Dremel them away. Once I've Dremeled everything, I wanted to roughen the inner plastic to glue the new fan in with some 2-component glue. I later used a vise for the whole thing so the glue can get hard while staying in place. Now I want to roughen up the inner case right where the case fan component sits and use adhesive to keep it in place. Here comes the most difficult part of the build. I need to align the chassis to the correct height so that the power button can be pressed correctly like you would do on regular original GameCube hardware. So I positioned it right where the original piece with the fan was. This was a pure try and error game, and I recommend using a custom 3D printed mounting bracket for the button. However, this might be something maybe for a future 2.0 version of my build. Once I positioned everything correctly, the fan should be able to blow out air through the case's air exhaust. I've bought a third-party GameCube to USB adapter and removed the case from it. This adapter is great as it has a bit of wiggle room between the board and the actual ports, which is great to position them later. Now I want to modify the original housing for the controller ports and replace them with ports that can be wired to USB. I removed the original board and then melted away all the plastic standoffs that would interfere with the new ports. Now I want to position the controller ports as evenly and centered as possible. To keep them in place permanently, I carefully melted around the port right where the black piece touches the grey port housing, melting the two plastics together. Unfortunately, I mixed up the correct order of the ports and they are now upside down. However, we can remap the controller ports later in Dolphin, so port 4 points to player 1. Thankfully, I can route the USB connection inside the case to the motherboard's USB header that I will use for my adapter board. Therefore, I desoldered all connections of the adapter board and soldered jumper cables directly to it. Now that I've soldered all the jumper cables to the board, I want to add adhesive all around the ports so they sit tightly in place and have a strong connection to the actual port housing. Remember, they need to handle the plugging and unplugging of controllers. So let's add a bit of hot glue around the soldering points to secure them as well. Now I need to connect the cables to the right ports on the USB header. I drew this little sketch that shows the connections in detail. On the right you see the controller adapter board and on the left you see the motherboard's USB header. First of all, please ignore those two cables already sticking out of the power button piece. I first soldered the wrong connection and they will be removed in a few moments. I need to remove as much plastic on the top until I'm able to solder wires to the PCB. As you can see, I already soldered the wires right under where the actual electric switch sits. Take a look at the PCB. The outer soldering points are actually already occupied by the switch to hold it. I want to solder two jumper cables to the inner points. Afterwards, I added some glue on top of the PCB to secure the connection. They now go into the motherboard's power button ports. This is definitely not the cleanest and best way to do that. However, it gets the job done and works fine for me. The original power light of the GameCube sits right on the same board as the original ports. I removed the board, so now I have to install a new power light with some fancy RGB lights. I bought cheap, low-voltage USB LED stripes and rewired them to two jumper cables and plugged them directly into the designated power light ports on the motherboard. They should glow now once the PC is running. I will now line the LED stripes as good as possible onto the little transparent plastic piece. The light should shine through that. Also here I added adhesive on top of it to secure it into place, while leaving a bit of wiggle room before and after the actual gluing point. I also routed the stripes further into the case so they can shine out of the case's exhaust grid. Now it's time to close the GameCube for good. But not until we've tested the system with everything hooked up. I've installed the OS and the emulator with my GitHub project beforehand, so let's take a look now. Once I press the button, the PC immediately turns off again. That's because the motherboard only accepts a momentary press. However, the GameCube's power button stays down once it's pressed, therefore simulating an ongoing power button press which cold resets the PC after some time. Pressing it twice quickly, however, does the trick. As you can see, the PC turns on, showing us a boot screen and emulation station interface with a fully working controller input, case fan and power light. Note that this video was shot before I glued the new power LED down to test everything beforehand. After securing all cables with some more hot glue so they don't fall off the motherboard, I now want to glue the controller port housing into the case. We want to add adhesive all around the grey housing once it's positioned correctly within the case. Next, we roughen up once again the edges of the case and clean them afterwards with some alcohol to remove any dust. I also forgot to mention that I've also glued the IOShield into the motherboard. Now I carefully close the case and pour 2-component glue with its corresponding granule into the gaps between the two case halves on all sides. Now we want to apply some weight that is equally spread across the GameCube for one day. Good thing I had another GameCube sitting around. Now let's give the whole thing a good clean. Notice that we have a big opening right above the IOShield, which just looks awful. We need to fix that next. Oh, and don't forget to clean the logo plate. I've cutted out a thin aluminum plate to the correct size to cover as much of the IOShield and the gap between the case halves as possible. Of course, I'm going to glue that as well and give it one last cleaning touch with alcohol. Let's take a look at our finished sleeper PC. Now we turn the system on and see what happens with a TV hooked up. What a relief! Everything works fine with the controllers and the software working and running as expected. And the system does perform extremely well. 2 hours of gameplay in Metroid Prime at 1080p with 4x MSAA anti-aliasing, a 16:9 aspect ratio and 60 FPS showed a great average performance. With an APU usage at 40% and the APU temperature not going above 50 degrees Celsius at 3.3 GHz clock speed. As you can see, the RAM is extremely underutilized, coming in at only 1.07 GB of usage. It is time for our final conclusion. I've reached all of my goals that I wanted to achieve here, except for the proper power light. For some reason it just stopped working after I closed the case, and it won't come back up again by itself. This build was definitely one of the hardest things I've ever built, and believe me when I say that I ran into many problems until I got the direction that worked for me. Once again, I wanted to mention the corresponding GitHub project, which has everything we've covered in this video more detailed, as well as the corresponding code that transformed this little PC into an emulation appliance that got as close as possible to the original boot sequence and user experience. Thank you so much for watching, and now what's the best way to end this project but with some actual gameplay captured directly through the HDMI output of the system. I will add the live frame rate counter from Dolphin in the upper right corner after a few seconds within the video. The games are all configured to run at 1080p with 4x MSAA at the highest possible frame rate and in most cases with a 16:9 aspect ratio. Please enjoy.
Look over there, PK. That's an activation.
Ah!